And we need to see what number is the most popular among these. So if I start with 19, I can see 2, 3, 4, looks like 4 number 19s. Okay, 4 of them. And looks like other numbers also repeat. So I don't see that 20 repeated. I see 17 repeats. Let's see how many times. 2, 3, 4, 5, 6 of them. Oh, looks like good morning, good morning. It's great, we're all here. So it's definitely not 19. So let's see if 17 is there. So it's great, we are all in this wonderful class, right? So next I see 21. So I see 1, 2, 3, only 3 of them. Okay, so it seems that 18 is also popular. So 18 appears 1 times, 2, 3, 4 times only. So the popular number, the most popular, we call it as a mode, then will be number 17, right? So that's for the mode. Well, I was in such a good mood that I gave everyone full credit for the quiz, even if someone said it's also 19 and it's also 18. So, but the point of story, the mode is the most popular. So that's the one that you were supposed to answer for a quiz. But again, I understand that you see it first time I ask you, you may not get it right from first trial. So I still gave a full credit. Now the question is, what about homework? So for the homework, we don't have every odd number. In fact, the syllabus for this class, let us check out the syllabus for this class, because that's the document that you can always refer to when you are not sure. So here's our syllabus for statistics. It says not every odd, but every second odd exercise in the syllabus. So let me try to open this up here. And you can see that in the syllabus, the next page is talking about the homework assignments. So it says every second odd. I even listed the problems that you can try. They belong to every other or every second odd. So that's what we have for the syllabus. So it turns out that we started our course material with chapter 2. So it's not chapter 1, so it's chapter 2. So the first section was 2.3, 2.2, right? And then we went to section 2.3. So far for homework is section 2.2, 2.3, and now we're working on section 2.4, and there'll be more of chapter 2. So I would say, etc. That's why when you do your homework, you don't have to send it to me as of yet. I say, so Alex, when do I send it to you? Well, in the syllabus I wrote, homework is due on the day of the exam. So if you, again, check with the syllabus when we have our exam day, so it's on the bottom of it, then you can see that the midterm exam is going to be on the day of, on Tuesday, the 18th of October. So that's about a month and a half from today. So you still have time before that day to turn in your homework. And I will cover not just chapter 2. You can see I also cover chapter 3, I cover chapter 4. So I want you to send me the whole thing, the entire homework on the day of the midterm. We'll see how far we go. Maybe we'll cover a little less than the syllabus says. That's why it's not the due day as of yet. So just please do something outside of class and just save it, and later when the day comes, I'll ask you to email me your work, and that's how one should do this. So I'm glad that you concerned about it, that you are doing something for homework, but don't send it to me as of yet because it's another month and a half before it's due. So we looked at mode, and we also try to find sample average, or so-called sample mean. And today I would like to show you how to find sample average much simpler. So remember, we had a formula here. So to find the sample average, they called it as a sample mean. We used to get this special, let me get there, the special formula. It's in the beginning of the section, so let me go there. So just show you how they do it, and it's right here. So you can see this little sample with 6 elements. So yes, thank you for reminding me. I already set this to record. That's very important indeed. So we have size 6 of the sample because it has 6 pieces of data. So I'm gonna have to put that sample size in my denominator. So my denominator will be number 6. And then I have to add all of these numbers together. And it's being shown here by special symbol sum of elements of sample. So we add this all together and produce the result. So it turns out that I can actually do this process without adding those numbers together, but entering them into a calculator. So to do this, I can copy this sample. So I just right click and select copy. Then I go to find the special calculator, which is called standard deviation calculator. Oh, when you say that's something new. Yes. So today we're going to talk about the standard deviation, and I'm showing you that special calculator. So I'm going to select that calculator, and then I will put comma after every number in it. So they give you here a sample that shows that you need to paste the data in it. So I just right click my mouse and pasted data. Okay, so now once I have clear the memory, data is pasted, definitely I should share this calculator with everyone. So it's called standard deviation calculator. It's a new word for you, and it's a statistical term. And well, you will get used to this, no worries, toward standard deviation, because it will be with us from now on daily basis, pretty much. So the standard deviation calculator is here, and I need to, of course, find a standard deviation, not for population, but for my little sample of 6 numbers. So I have to put commas after every entry in this sample. I enter a little comma like that. And then, well, then I need to select calculate. And to calculate this standard deviation, I get some number. But the point of story is that right now we found the sample mean, and this is X bar. Remember, they called it as X with a bar, and the name of it is mean. When you say, Alex, this is the average, it's the same thing. The average or sample mean, it's the same exact thing, and it's equal to, well, something like that. 3, 3, 3, 3, 3, dot, dot, dot. So that's what, if I go to the textbook, I'll see that's what the actual textbook produced as well. So looks like you can use this special calculator to get the sample average calculated. Let me return back to this result, as well as some other value. Since we already started to talk about it, it's called a sample standard deviation. They use letter S for standard deviation. Not surprising, right? And it's a 1.914. I'm not going to put too many digits like dot, 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 and so forth. And the question is, of course, what is that we just calculated? What does this mean? And what is this for, this word standard deviation? Because we definitely know what the average is for. That's like a center of the sample. So it's approximately 1.5, one can say, right? If you look at this number, you can just say it's about 1.5 or something like that. Now, standard deviation shows us how far the sample elements could be away from the center. So the ballpark, in other words, for the sample elements. So if your standard deviation about 1.9, right, approximately. So I could spread my sample data 1.9 to the left, approximately, and 1.9 to the right. So if I add 1.9, it'd be something like 3.4. And if I subtract 1.9, it'd be like a negative 0.4. So add and subtract to show the ballpark for all the sample elements. And you can actually look at these sample elements and see that the largest is 5.4. It's all the way here. The next is 1.1. So this is, well, probably here to the left, right, from 1.5. Then we also have 0.42, that's smaller, it's someplace in here. 0.73 and 0.48, so those two numbers are here, and 48 is somewhere there. So you can see that pretty much all of these elements of the sample are falling into exactly the same region. And one can say, looks like, Alex, they all fall in here to the left from 1.5. Yes, and probably because of this very big number compared to all of them, we have the sample kind of shifted its mean to the right, and standard deviation because of it, because of that number, the big number 5.4 happened to be so large. Because technically, without 5.4, all sample elements will be within a much smaller little region. And that makes people wonder if that 5.4 is a correct number, or maybe just put it there by accident. Maybe it's just a mistake in collecting data. Well, who knows? We're gonna talk about this later. But I was able to picture my sample with its center mean 1.5 or 1.53, whatever, and also show the level of how sample elements should spread to the left and to the right. And that level of spread, or so-called standard deviation, is what I plan to talk about today in a little bit more details. In fact, this formula that our new calculator was dealing with, let me go back here and again back. So they'll show you the actual formula right there. You can see it here on the right side for standard deviation. That's what going to try to justify right now for you. So it'll make a little bit more sense why it looks, some people say, so nasty because it's a square root and there's something squared and everything else is here. So let me get a piece of a board. I'm going to share a board here and discuss the idea of standard deviation. We didn't talk about it yet, right? About standard deviation in our class, or you already saw this before. Please let me know. That's something new, right? You say, Alex, what are you asking about? Well, I just want to make sure that I don't talk about it again, because if you already saw it, then it's okay. But I want to talk about standard deviation, which is a letter S for standard deviation. And the formula for it, as we just saw, was a x minus sample mean squared. And then it's added with another element of sample, which is another x. So I put that symbol called sum. And I divide this by number of elements in my sample, which is n, which is actually n minus 1. And then extract the square root. And that's how we actually should produce that so-called standard deviation. So the spread of sample elements around the center, around the sample mean. So my goal right now is to justify why this formula is making sense. So for this, I can take a sample with nice elements. I like sample with elements like 1, 2, 3, 4, 5. Well, maybe that's enough. 5 element sample. And calculate its mean, calculate the average of the sample, which is going to be the sum of all of those elements, right? So I need to add all of them. 1 with 2 with 3 with 4 with 5. And of course, divide by the sample size, which is 5. So when I add these elements, I'm going to get a number 15. And when I divide this by 5, I get the 3 as a result. So the average for this sample is 3. Let's calculate its standard deviation. How can I do that? Well, what I need to see is how far the elements of my sample will be lying away from the average, away from the sample mean. So the elements are 1, 2, 3, right? Then there is 4 and 5. So there are 5 sample elements. So when I try to find the distance from my sample elements, that average distance, I guess, right, to see what would be the average distance from each element to mean, you would say a couple of elements on the distance of 1 and a couple of elements on the distance of 2. So 1.5 is probably the average, right? Geometrically. So the question is, how do we find this algebraically? And then from each element that I have, such as 1, 2, 3, 4, and 5, I should find a gap between the sample mean, which is number 3. So if I was to subtract that number 3, the sample mean from each element, and then average this, in other words, add all of these differences together, so I put the plus in between, then I should divide it by 5 because there are 5 of these elements. So the total of these pieces is 5. So I'll average divide this by 5. But we are running in a little bit of a problem here, because when I subtract 3 from 1, it's a negative 2. And when I subtract 2 and 3, it's a positive. It's negative 1. Then I get plus 1 and then plus 2. So if I decide to add these differences, they'll cancel each other out, right? Because -1 with 1 will cancel, and +2 and -2. So for that reason, people square these differences so that minuses will disappear. See why you square? So your minuses will disappear. But then you also need to extract the square root because you square. So you have to go back to what you used to have. So you also square root. So that's why in that formula we have a square. So this minuses will disappear and then extract square root to get back. And they also subtract 1 in denominator. The reason is that one of these differences is always 0. One of the differences, turns out, is not going to give you any raise to the actual sum. So I'll divide by not 5, but 4. And what I divide will be 2 squared, which is 4, plus 1 squared, and then 0, and then another 1, and then another 4. So when I calculate these together, add these together, I'll get 10. So it'd be a square root out of 10 divided by 4, and that's actually 2 1/4. So if I square root 2 1/4, it's going to be about 1.5. And that's exactly what we have intuitively estimated when we looked at the gaps of 1 and 1, and the other gaps were 2 and 2. So you can see that between 1 and 2, there is 1.5, so that should be the average. And that's actually what the standard deviation is all about. So in my nice looking example with nice looking numbers, we can get a bit of intuition into formula. So I'd like to, for comparison purposes, get another sample like elements 1, 1, 3, 5, and 5. And this way, I can also calculate mean and standard deviation. Analogously, for sample mean, we add these 5 numbers all together and divide the sum by 5, right? So we have 15 divided by 5. And when I do this, I get average equal to 3. So sample mean is 3. And then to get a standard deviation, it'll be the same thing pretty much because my sample mean is in the center, right? 3. Now look at the sample elements. They are on the distance of 2, right? Because there are 2 1s and there are 2 5s besides 3 in the middle. So when I try to get the standard deviation, then I'll be extracting the square root from denominator is 1 less than 5, right? So I take each element of the sample, 1, 1, there is 3, 5, and 5. Please notice that these elements are here, right? And minus from each of the elements, my number 3, my sample mean, just like that. And I want you to notice this is not the best calculation that people actually produce because it's a pretty tedious one, right? So that's the reason why I show you how to do this with a calculator, because when you start to square all of these differences, add them together, it's so easy to miscalculate some of this arithmetic. But the calculator will definitely do this correctly for you. So notice that here you have -2, here you have also -2, here is a 0 when you subtract, right? +2 and +2. So when I square these guys, I'm going to end up with 4 plus 4 and then nothing. So I put a 0, and then another pair of 4s, like that and like that. So we got 4 of these 4s, and I divide the sum by 4 and end up with a square root from number 16 over 4, which is just a 4. When you say, oh, the square root from 4, I know what it is. It's number 2. Yes, exactly 2, as we already probably thought that each element of my sample is on a distance 2 from the center. Do you see that each element of my sample is 2 units away from sample mean, which is 3. Of course, with exception of one element that we kind of disregard by subtracting 1 in denominator. So you can see how the formula arises from every element in the sample, like 1, 1, 3, and so forth. From every sample element, I call it as x, I subtract mean, I subtract 3. So we find this gap in between of the elements of sample and sample mean. And then we average this gap, so we divide by n minus 1. So we add them all together and we square and then do the square root to kill the minuses. So that's what the formula actually is for. And this formula appears in the section that talks about measures of variation of sample elements. So this formula actually appears somewhere. Where is it? Variation. It's here. And oops, I need to actually share the screen with you, right? So let me share because you don't see it. So I just found this formula in a textbook. So that's the one that talks about sample standard deviation. But once again, I don't want to use this formula because it's very, very inconvenient. In fact, there is a shortcut formula. They say, well, the shortcut is use a calculator. Don't use any formulas so you get the numbers by hand calculated, because it's just very, very tedious. You can see they create tables, they subtract. So this is taking a while. So to do one exercise will take you probably half an hour with pretty bad numbers in the sample. But you put what in the calculator? You want to make sure you put carefully in the calculator, make sure you put the same exact thing, because if something is mis-entered, it will be definitely a different answer. So, because unless calculator is malfunction. So let me see, where did I do it? Oh, it's on the board. So let me share it. So you can see that we enter each element. It's all here. It's all in front of us. So here's the first number, 1, right? Subtract 3, it's -2, it's right here. And then you square it. So you square it. Next is 1 minus 3. So again, it's -2, you square. Notice when you square -2 is 4. Square another -2 is 4. 3 minus 3 is 0. Then square 2, 5 minus 3 is 2, you square it's 4. And here's another 4. So you add these 4 fours is 16, divide by 4 is 4, so square root of 4 is 2. So the point is you need to make sure that you subtract 1 in your denominator. Maybe that was the thing that you should fix, because if you have sample standard deviation, it needs to be n minus 1 in denominator. And you can see intuitively again that the spread of every element around the center is actually 2 units, because it's difference between 5 and 3, or difference between 3 and 1, it's also 2. So that's the thing. So again, the calculator that you should put it in will be the one that I gave you for standard deviation. And that's the one here, which is I just shared with everyone. So let's try. So I'm gonna put this back to our screen. So here's the standard deviation calculator. So let's see how we should enter these numbers in it. So we can do this again. So we can check and see if this works properly. 1, 1, 3, 5, 5. I think that's a very good question because it shows us how to use a calculator correctly. Please notice that you need to make sure that you treat this as a sample. That's the key part. And when I calculate this, I get my standard deviation, which is exactly 2, and the sample mean, which is exactly equal to 3. Maybe if you use a calculation for population, then it could be given us a little bit different numbers. So if you use population, but we have samples, so make sure that you have samples. So this is a great question, I think, because I'm sure that some people will forget to switch to the sample. So that's the only place one needs to be careful, because what we really trying to calculate here is a sample spread. How sample? So it's a letter S for the sample standard deviation. And here they show you how tedious all of these calculations are in the textbook. You can see these tables they create, and that's something I definitely don't want to do, because I want to just use a calculator. I want to use technology because it's so easy to get messed up with this. So why don't I try to find a standard deviation for the second exercise? It talks about Harry Potter and 12 pages of the textbook. So whatever they talk about is definitely fun to know, but how about finding the standard deviation for the sample? And of course, I also be able to find a sample mean here as well. So let me show you how we can use that calculator once again. So I will share it. Looks like some people just logged in, so I can share in the chat once again this standard deviation calculator with everyone. So it is in the chat. You can just click on that link, and of course bookmark it, right, like that, so you can have it saved somewhere in your computer, the link to this. It's free, totally free calculator, no obligations like emails. So some calculators say, oh, put your email somewhere, we're gonna send you spam. Well, you know, no, this calculator is not doing anything like that for you. It's just free. So it looks like we got no. So we got this sample, and I want to show you how to enter it correctly in this calculator by copy and paste. So you copy first part of the sample. So I'm going to put this in my new calculator, the first part, and then get pasted like that. So we can put commas after each entry carefully. So it turns out that all of these sample elements are not going to be entered. I already tried, because I guess try to copy the whole thing at once. Notice there are 2 rows of data. So I noticed that if I copied the pair of rows right away, it wouldn't paste in my case correctly. You can try if it works in your case, but I don't have a problem just copy another row. Just make sure there is a comma and then space between each element, because otherwise, well, the calculator will give you something else. So you want to make sure there is comma and then space. So this way you separate it. Your looks like there are 6, 8, 10, 12 elements here. And now again, I make sure it's treated as a sample. So I calculate this as a sample of size 12. Notice they show how many elements we have here. And we also see that the average came out as a 80.75. That's my sample mean, right? The sample average. And also I got a standard deviation, which is a little bit more than number 4. So this is 4.681, dot, dot, dot. So we have the sample of Harry Potter book, whatever they're talking about here. I'm sure this is exciting story. I like this book. When I try to read it, I get asleep, so it helps me a lot. So X bar, the mean, is I would say about 81 approximately, something like that, for convenience, just to show you what we just found. Remember the same picture already did, and the spread is about 5, let's say. I round it to 5 just to get nicer numbers. So if you go 5 to the left and 5 to the right, it's always left, right. So it gives you a ballpark. Then add in this 81 with a 5, I get 86. And when I subtract number 5 from 81, it's going to be something like 76, right? So sample elements, approximately, not exactly, are in between 76 and 86. Let's see if it's true. So notice that 85 here, so they're no bigger than 86. There is 86.2. There is one element that seemed to be slightly, very slightly out, but that's fine, right? And now, so I'm adding and subtracting 5, right? So 576 plus 5 is 81. And then we go with the lowest part. So what's the lowest I see here? When I say, Alex, I see 70 here. There is one that is far away. So somewhere all the way, I cannot even put that far. So somewhere outside, that 70.9 is the lowest. But there are no other elements here. There's 74, which is next to it, right? 74, so it's like another. But they're not too far away from my center, and that's the whole point. So you know it's not from 0 to 1 million. Well, it's in between about 76 and 86, maybe 74, something like that. So it gives you a ballpark to approximate these numbers that were produced. So that's why the point of story is that sample mean, the average, may not be a very good estimator for your numbers, because you may still have same exact average 81, but one number may be a 0, and the other number may be something like 181, and the average will be like 182. The average, if you add this together, or 62, and divide by 2, it'll fall into 81, but one number is 0, the other is 162. That's way more spread than we have here with standard deviation 5. You see, because otherwise your standard deviation will be like 80, which is a lot. So the point of story, the smaller is standard deviation, the better is the sample, the more consistent it is. So we want to make sure that everything is nice and consistent, so we have a good prediction. So today I would like to just practice using this calculator for standard deviation. So I'd like to do another exercise to make sure we select sample and we get ourselves a nice little number. So maybe I can find another problem to do. How about problem number 9? I can do first part of it And then you can try for a quiz the second part of it. And the second part will be same as the first part. All you need is to just do the same process with finding standard deviation as I will do right now for the first part of exercise. So let me show it to you again. So first of all, I want to copy these numbers and paste them. So you can just copy like that, right? And then paste. Oh, first you copy, click on copy. And then you go to your calculator, which is my, where's my calculator? Oh, here it is, it went in front. So I go back to the sample, clean all of these data, right? Clean all of the delete, and then paste. So again, right click the mouse and here's the choice paste, right? Copy and paste. And that's the advantage of this calculator. You don't need to worry about the data. Just copy paste, but make sure you entered commas in between. So you have this commas, commas. Try to do this at the same time with me. So put those commas, because once you entered a few commas, then you're pretty much done, right? Just don't forget that it's your sample, right? So we need to make sure that sample is highlighted here. And then I click on calculate. So I calculate this sample average. So I just click here and calculate. And there we go. I found it. Here's my standard deviation. So I can write it down. When you say, Alex, can I round it? Yeah, you can round it. As long as you got this estimate, it's like 0.4766, some dot, dot, dot. This is your answer for standard deviation. So it's like complete use of calculator. And that's what I would like you to try to practice. I know some people may say, Alex, I just don't like these calculators. Believe it or not, I don't like them. Well, it's okay. You can practice this on your own later then, and just email me what you have produced. I will accept it, no worries. But try it right now. So copy this data and find the standard deviation, what this is. Put this in the Zoom chat. Of course, without a hurry, just send it to Alex, not to everyone in class. Somebody already did it, that's great. And then after that, well, I guess that's it. So I'll give you plenty of time to do this.